we're going to balance reactions now, which is a pretty easy thing to do. I'm assuming that you have some experience doing this, but it doesn't hurt to practice and to try. Okay, and so when you're balancing chemical reactions, there are different approaches you can take. When you're balancing redox reactions, which we'll do later, it's a little bit more complicated. But when you're balancing kind of simple reactions, you can use them usually by trial and error. Okay? However you balance them, the important thing is that all of the atom types have to be balanced, meaning that the numbers of each types of atoms have to be exactly the same on the left side and on the right side, which is really just conservation of mass. Okay? You can't change the formulas of anything, but what you can do is use different coefficients in front to make things work. Okay? As a good rule of thumb, try to balance the compounds or the atoms that show up in the least number of spots first. Okay? Contrary to what you may have heard before, it's perfectly okay to use fractions if you need to when you're balancing this. Unless, of course, the question says, balance this equation using the smallest whole number coefficients. If you need whole number coefficients, then what you can do is just multiply everything by whatever the lowest common denominator is. Okay, so let me give you a specific example of how to balance a chemical reaction. Let's say you were interested in the combustion of ethane. Okay, and so the first step is going to be to write down the reaction. Okay, and so we're going to start with ethane, which is C2H6, and we're going to burn it. That's what combustion is. So we're going to add oxygen to it to make carbon dioxide and water. Okay, so those are my reactants and my products, right? C2H6 plus O2 yields CO2 plus H2O. Now I have to worry about the coefficients. So let's see who shows up where. Okay, I have carbon here and here. That's 2 spots. I have hydrogen here and here. That's 2 spots. I have oxygen here, here, and here. Ooh, 3 spots. Bad. So let's do the oxygen last. Because the carbon and the hydrogen both show up in the same number of spots, it doesn't really matter which one I do first. So let's balance the carbon first. I have 2 carbons on the left, so I'm going to use a coefficient of 2 to balance it on the right. So I have 2 CO2. Then I'm going to balance the H's. I have 6 H's on the left, but I only have 2 H's on the right. I need a coefficient of 3, right? 3 times 2 is 6. So now the hydrogens are balanced. Now the thing that's left over is the oxygen. Okay, so on the left side, I have 2 O's. On the right side, I have 4 O's from here. 2 times 2 is 4. And 3 more here, right? 3 times 1 is 3. 4 plus 3 is 7. So somehow I have to make 2 equal to 7, right? How the heck do I make 2 equal to 7? Well, I can multiply by a decimal or a fraction. That's okay, right? I can use 7 halves or 3.5. So if I use a coefficient of 7 halves in front of the oxygen, that's going to make it work out. Okay, so here's my 7 halves O2. If this really bothers you or the question says whole number coefficients, then I just have to double everybody. And so now I have 2 times C2H6 plus 7 O2 yields 4 CO2 plus 6 H2O. So this would be my balanced chemical reaction using whole number coefficients. Now I said it a minute ago, balancing redox reactions is a little bit harder. Okay? The key to balancing the redox reactions is to make sure that all of the electrons that are lost in the oxidation step are gained in the reduction step. Okay? And so I have to have a balance. Okay? The number of electrons that I lose has to be the same as the number of electrons that I gain. And so I might have to use coefficients in front of each of these reactions, which is called a half reaction. So let me give you a little bit more specifics about exactly how this works. Okay, let's say that we were interested in this reaction. Okay, disproportionation of bromine, Br2, into bromide, right, Br minus, and bromate, BrO3 minus. Okay, first thing I want to do is figure out what the 2 half reactions are. So let's look at the oxidation numbers. Okay, here the bromine has an oxidation number of 0. Here it's -1. And for this case, it's a little bit different, right? The oxygen is -2. I have 3 of those, so that's -6. That means that this bromine has to be +5, right? +5 and -6 gives me an overall charge of -1. So you can see that some of the bromine got reduced from 0 to -1. Some of it actually got oxidized from 0 to +5. So let me write down both of the half reactions. Okay, so here's Br2 forming Br minus. Okay, this is -1. So now to balance this, I can stick a 2 in front. Okay, so now I have 2 Brs. And now I have to balance the charges. Okay, so here I have -1 times 2 is -2. This is going to require gaining 2 electrons. So now I have -2 on both sides. Now for the other reaction, I'm starting with Br2 and I'm forming BrO3 minus. Okay, same deal. I need a 2 there to balance the bromines. But now something interesting is happening, right? I don't look at the negative, I look at the actual oxidation numbers. This went from 0 to +5. But since I have 2 of them, that's really +10, which means that I have to gain 10 electrons on this side. So now the charges are balanced, but the O's are not, right? I have 3 O's here and no O's on this side. So I'm going to have to add 3 H2O's on the left to balance the oxygens. And then I have another problem, right? I don't know if the solution is acidic or basic, because now I've added H around and there was no H to begin with. And so what I can do is, to balance the hydrogens, I can add 6 H plus ions on this side. And this would be fine if it was acidic. Okay. If the solution is basic, then I have an extra step. Because if the solution is basic, I can't have H plus ions lying around, but I can have hydroxide ions lying around. So I need to increase the amount of OH minus. And the way that I do that is by forming water. Okay, I can say that H plus and OH minus make H2O when they combine. So since I have 6 H plus ions here, I can add 6 OH minus here and 6 OH minus here. So then when I add this up, okay, 6 H plus and 6 OH minus together give me 6 H2O. And if you look, it's kind of interesting because on this side I have 3 H2Os, and this side I have 6 H2Os, so I can cancel some of them out. Okay, so I still have 6 hydroxide ions here, plus Br2 yields 2 BrO3 minus, plus 10 electrons, plus 6 H2O. And I still have my other reaction, right? Br2 plus 2 electrons yields 2 Br minuses. So now the important thing is the charges have to balance. The number of electrons that I lose has to be the same as the number of electrons that I gain. So I have to multiply this by 5 so that I can lose 10 electrons in the first step and gain 10 electrons in the second step. So now if I just add all of this together, I have 6 OH minus plus 1 Br2 and 5 Br2s is the same as 6 Br2s. Okay, and I have 10 electrons. That's my entire left-hand side. My right-hand side is 2 BrO3 minus plus 10 electrons plus 6 waters, and I still have 10 Br minuses from the bottom half reaction. So now I can cancel some things out. Okay, notice that I have 10 electrons here, 10 electrons here, those go away. And I can do something else. I can divide everything by 2 because everything is divisible by 2. So if I do that, I get 3 OH minus plus 3 Br2 yields BrO3 minus plus 3 H2O plus 5 Br minus. So there's my balanced redox reaction for the disproportionation of bromine to bromide and bromate.